Hello everyone. In this lesson, we will be discussing the alternative definition of the derivative. So we have this alternative definition because there are some functions wherein if you are going to compute for the derivative of those functions, you cannot solve it using the original definition. That's why we have this alternative definition. It can solve those derivatives na hindi kaya ng original definition. For example, suppose we have the function f of x equal to sine x. And suppose we are going to find for the derivative of the function f at x sub o equal to pi over 2. So we will find f prime of pi over 2 here. Okay? Now, using the original definition of the derivative, that is just f prime of x sub o is equal to the limit of f of x minus f of x sub o all over x minus x sub o as x approaches x sub o. Okay? Now, substituting our x sub o is just equal to pi over 2. So we will now have f prime of pi over 2 is just equal to the limit of f of x minus f of pi over 2 all over x minus pi over 2 as x approaches pi over 2. Now we need to solve for the value of f of pi over 2. So solving it, we will have f of pi over 2. We will just substitute pi over 2 to our x here. So we will have sine of pi over 2. And we know that sine pi over 2 is equal to 1. So therefore, this will become the limit of f of x is equal to sine x, which is our function. So we have sine x minus f of pi over 2. We have computed that 1, and that is equal to 1 all over x minus pi over 2 as x approaches pi over 2. Now, in this case, if we will do direct substitution, sine of pi over 2 is equal to 1. Then minus 1, you will have 0. Over pi over 2 minus pi over 2, you also have 0, which is indeterminate. So in this case, if we have an indeterminate form, the limit of those forms, 0 over 0, may exist. And sometimes we can solve that one using factoring or rationalizing. In this case, we cannot factor this one nor rationalize. And we cannot also apply the special limits that we know for sine. Take note that the special limit for sine is given by the limit of sine t over t as t approaches 0 is equal to 1. Now, magagamit lang natin to if we have sine t here, whatever your argument here, if we have t, the denominator should also be equal to t. Now, in this case, we have x. Now, in our denominator, this is not just x, but we have x minus pi over 2. So, therefore, we cannot apply the special limits that we know. So, in this case, mahihirapan talaga tayong isolve itong problem na to. That's why we have this alternative definition. So, ano ba yung alternative definition? So, mamaya, we will try to solve this one using the alternative definition. Okay? So, to continue, let's recall that if we have a function f defined on an open interval I, subset of the set of real numbers, and we have x sub o element of the open interval I, the derivative of f at x sub o is defined to be this one. So this is the original definition of our derivative. If this limit exists, right? Now, in this case, we know that the derivative of the function is just the same as the slope of the tangent line of that function at that given point. Now, suppose we have this xy plane and we have this function y equal to f of x. And suppose we have this point P here. So therefore, most probably, our tangent line will look like this one. And to solve for the derivative, we are just solving for the slope of that tangent line here. So we need to solve for the slope of this tangent line. And to solve for the slope of the tangent line, we will just solve for the limit of the slopes of the secant lines through point P. So therefore, we need to consider all secant lines through point P. And suppose this is our point Q here. So therefore, this is our secant line. Now, suppose our P has the coordinates x sub O, y sub O. So therefore, this is x sub O here, and this is y sub O here. And suppose Q has the coordinates x, y, then we have x here, and we have y here. Okay? And from that, to solve for the limit of the slopes of all secant lines here through point P, we will just solve for the limit, right? And that limit will be the limit of, so this is the slope of the secant line, tangent line, that is equal to the limit of the slope of the secant line. And the slope of the secant line is given by y minus y sub o all over x minus x sub o as x approaches x sub o. We have already discussed this one in our previous lesson. Or that is just given by the limit of f of x minus f of x sub o all over x minus x sub o as x approaches x sub o if your function is given in terms of f of x, right? Now, in this case, suppose I will let h be equal to x minus x sub o. So therefore, h now is just the distance of x from x sub o. So the distance of x from x sub o is now equal to h because I let h be equal to x minus x sub o, right? Now take note here, our point Q will approach point P. As your Q approaches P, x will approach x sub o. And if that happens, your distance h will decrease and it will approach to 0, right? As your x approaches x sub o, yung distance natin dito ay liliit and it will approach to a 0 distance. So therefore, as x approaches x sub o, h will approach 0. Okay, and since we let h be equal to x minus x sub o, our variable now is h. So siya na yung mag-change. So therefore, this x here will be changed. And from this equation here, x is just equal to x sub o plus h. We just added x sub o to both sides. So we have this one. So therefore, our function now will become, or our derivative will become f prime of x sub o equal to the limit of f of x. X now is equal to x sub o plus h minus f of x sub o all over h. And once again, our variable is h. And as your x approaches x sub o, h will approach 0. And this is now our alternative definition. So ito na yung gagamitin natin to solve for the derivative of those functions na hindi kaya ng original definition. Okay, and this limit or the derivative will only exist if this limit exists. Okay, so once again, the alternative definition is given by f prime of x sub o equal to the limit of f of x sub o plus h minus f of x sub o all over h as h approaches 0 if this limit exists. So ito na ngayon yung gagamitin nating formula in finding the derivative of the function at x sub o. Okay? So to understand it further, let's consider the following examples. For number one, we will compute the derivative of the function at the given value of x sub o. So here our function is x squared minus 3x plus 1, and our x sub o is equal to 1. Okay? Now, based on the alternative definition. So we will apply here the alternative definition. Okay? So the alternative definition is given by f prime of x sub o equal to the limit of f of x sub o plus h minus f of x sub o all over h as h approaches 0. Now take note, we can only solve this one if we know f of x sub o plus h and f of x sub o. So let's solve first for these two values. Okay, so let's start with f of x sub o, and that is just equal to f of 1 since x sub o is 1. So we will just substitute 1 to our function. So substitute 1 to your x's here. So we will have 1 square minus 3 times 1 plus 1. And this is just equal to negative 1, right? So from that, we already have x sub o, f of x sub o equal to negative 1. Okay? Next is f of x sub o plus h. So this is now composition of functions. So all x's will become x sub o plus h. And since we already have the value of x sub o, this will now be equal to f of 1, which is our x sub o plus h. So you substitute 1 plus h to your x's. Okay? So from that, we will have si x dito magiging 1 plus h at yung x dito magiging 1 plus h. So you will have 1 plus h square minus 3 times 1 plus h. Then you have plus 1. Then you simplify. 1 plus h square is just h square plus 2h plus 1. Then you distribute negative 3. So we will have negative 3. Then you have negative 3 times h, so you have negative 3h. Then you have plus 1. And this is now equal to h squared. 2h minus 3h is my negative h. 1 minus 3 plus 1 is negative 1. Okay? So from that, we already have the value of f of x sub o plus h. So we have this one. Okay? So we can now substitute. So we have f prime of x sub o is 1. So f prime of 1 is equal to the limit of f of 1 plus h minus f of 1. So we just substituted x sub o equal to 1 all over h as h approaches 0. So from that, we will now have the limit of f of 1 plus h is equal to h squared minus h plus minus 1. So you just copy that one here. So we have h squared minus h minus 1 minus f of 1 is equal to negative 1. So you have minus negative 1 all over h as h approaches 0. So from that, let's simplify. We will have the limit of h squared minus h, negative 1 minus negative 1. So this will become plus 1. So negative 1 plus 1 is 0. So h squared minus h na lang yung matitira. All over h as h approaches 0. Now, if we will do direct substitution, this will become 0 minus 0, which is 0 over 0, which is indeterminate. So therefore, we will factor this one. So for the numerator, the common factor is h. So what's left is h minus 1 na lang. All over h as h approaches 0. So from here, h is common. We can cancel out h. So we will have the limit of h minus 1 na lang as h approaches 0. And we can now do direct substitution. So we have 0 minus 1, which is equal to negative 1. And this is now our final answer. Now let us try problem number 2. Now in this case, our function is given by x plus 1 all over x minus 1. And we need to find for the value of f prime of 2. So in this case, our x sub o is 2. So the same with what we did sa number 1, we will first solve for the value of f of x sub o and f of x sub o plus h. And since our x sub o is 2, so we will have f of 2. So we will just substitute 2 to our x's here sa ating function. So you will have 2 plus 1 all over 2 minus 1. And that is 3 over 1, which is just equal to 3. Okay? Sa second naman, we have f of x sub o is 2 plus h. So we will substitute 2 plus h to our function or to our x sa ating function. So we will have 2 plus h plus 1 all over 2 plus h minus 1. So from that, simplifying, we will have 2 plus h plus 1 is just h plus 3 all over 2 plus h minus 1 is just h plus 1. So this is now our f of 2 plus h. Now applying the formula, f prime of x sub o equal to the limit of f of x sub o plus h minus f of x sub o all over h as h approaches 0. So from that, we will have f prime of 2 is equal to the limit of f of 2 plus h minus f of 2 all over h as h approaches 0. So from that, substituting, f of 2 plus h is just equal to h plus 3 all over h plus 1. So we have h plus 3 all over h plus 1. Minus f of 2 is equal to 3. So we have minus 3 all over h as h approaches 0. Now simplifying the numerator, we will have the limit of the LCD is h plus 1. So we will just have h plus 3 minus 3 times h plus 1. Okay? All over h as h approaches 0. Now from that, we will now have f prime of 2 is equal to the limit of, so h plus 3 minus 3 times h plus 1. So let's simplify that one. We have h plus 3 minus distribute negative 3 to h plus 1. So we have minus 3h and minus 3 all over h plus 1. Then we have all over h as h approaches 0. So from that, we will now have the limit of h minus 3h is negative 2h. And 3 minus 3 is 0. So this will be canceled out. All over h plus 1, then all over h as h approaches 0. Now, dividing fractions, we will have the limit of, you copy the numerator, so you have negative 2h all over h plus 1 times the reciprocal of the denominator, and that is 1 over h as h approaches 0. And makikita natin dito na si h is common to both numerator and denominator, so we can cancel that out. So what's left is the limit of negative 2 over h plus 1 as h approaches 0. And this is equal to, using direct substitution, negative 2 over 0 plus 1, or just negative 2. And that is now our answer for number 2. Okay, so we have negative 2. Now, for the last example, we have f of x equal to square root of x plus 1. And we will find f prime of 3. So, our x sub o here is 3. Okay? So, first step, pareho pa rin kanina. We need to solve for f of x sub o. And since our x sub o is 3, so we will solve f of 3. So substituting 3 to our x, we will have square root of 3 plus 1, and that is equal to 2, right? And we need to solve also for f of x sub o plus h, and we will have f of 3 plus h. So you just substitute 3 plus h to your x, so we will have square root of 3 plus h plus 1. And that is equal to square root of h plus 4. Okay? So therefore, we can now solve for the derivative. So that is f prime of 3. And that is equal to the limit of f of 3 plus h minus f of 3 all over h as h approaches 0. So from that, we will have the limit of f of 3 plus h is just square root of 3 plus, no, that is square root of h plus 4. Okay, so we have square root of h plus 4 minus f of 3 is equal to 2 all over h as h approaches 0. Now, if you will do direct substitution, that will become square root of 0 plus 4, and that is 2, minus 2 is 0 all over 0. So, indeterminate. So, we will rationalize this one. So, we will multiply the numerator and denominator by square root of h plus 4 plus 2. So, we will just change the operation here. Whatever you multiplied sa numerator, we will multiply it also to the denominator. So we have this one. So simplifying, we have the limit of, so numerator, you multiply, so the result will be the square of the first term minus, always minus yan, square of the second term. All over, you copy the denominator, ipagtabi nyo lang, square root of h plus 4 plus 2 as h approaches 0. So from that, let's simplify. So we will have the limit of square root of h plus 4 square is h plus 4 minus 2 square is 4 all over h times, you copy, h plus 4 plus 2 as h approaches 0. And from that, we will have f prime of 3 is equal to the limit of h plus 4 minus 4 is just h. All over, you copy the denominator. So you have h plus 4 plus 2 as h approaches 0. And as you can see here, h is common. So we will cancel that out. What's left is the limit of 1 over square root of h plus 4 plus 2 as h approaches 0, and by direct substitution, you will have 1 over square root of 0 plus 4 plus 2, and that is equal to square root of 0 plus 4 is 2 plus 2, so we will have 1 over 4. And this is now our final answer. Okay? So that ends our discussion for the alternative definition. For the next video, we will provide more examples for this one. And in that video, we will consider um, the derivative of transcendental functions, like what we have yung sine x. So we will try to solve that one sa ating next video. So I think that's it for this video. Thank you for watching.